So, hello. This time we are going to learn about if statements. Uh, if statements are like important AF. So let me switch to dev stuff, tutorials. We have here test.c. So we left off with this, and we are going to learn about logical 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 oh logical truths and conditional. So logical truths are really important for understanding conditionals. So let's start by it. So we have a logical expression. Like for example, uh, e.g. Uh, 2 plus 2 equals 4. And another example is 2 plus 3 equals 1. So the first one is obviously true. The last one is obviously false. Okay? But if we put, what about that one? This one. Uh, let's not 2 plus 3 equals 1. Just in programming, we use the shebang symbol to determine not. So thing is negation. This is true because we are not true because we are negating the negation. It's getting a little bit philosophical and mathy, but it's really important. So we have here the truth table. Truth table. Not. Not. We call it not. So we have P and not P. When P is true and not P is false. And not when P is false, not P is true. Okay? This is important. Like really important. And we have the truth table for not. And let's try the truth table for and. So we have P and P and Q. And we have here the P and Q. Look at these symbols, like the two E's here. They are really important. I know it's getting a little bit like slow the tutorial, but this is really important. So if P is true and T and Q is true, P and Q will be true. If P is false, Q is true, this is false. P and Q is false. When the same thing but in different orders, it's false. And then when the two are false, P and Q are false. Okay? So let me put an example. I have I have 3 dogs and 1 dog. This is like false because I have 3 dogs and not 1 dog. So this is false. Let's let's make it big no. Because we have like, if the first one is true, the second one needs to be false. And then if the first one is false, the other one must be true. But we can have the both of them false. Maybe I don't have any dogs, but never will be true and true this time. And the only the only way to get P and Q to be true is if both of P and Q are true. Okay? This is really like strange, but yeah. And let me see how much time it passed. 5 minutes, okay. So we have here another one. True table. So we have again P P Q. Now we use P or Q. These vertical bars indicate or, okay? We are going to get writing some code later, just in a bit. So if the two are true, then the or is gonna be true. Is going to be true. But what happens if any of them, just one of them is true? Well, it will be true again because it's getting or, not and. Or is like uh inclusive, and then it's exclusive. And if both are false, it's false. Let me do this. I have 3 dogs or 1 dog. True. If on one of them, if at least one of them is true. Okay? So these are the basics. So now let's do something. Actually program something. Uh, let's create a little if statement. So to say to declare if statement with like we say if open parentheses. Oh, this by the way I learned that this right here is a comma. Like yeah, if 1 equals equals 1. But why double equals? Because double equals is like when the things are like you wanna compare them. When you have one equal sign, you wanna assign something to a variable. I'll explain later what variables are, but yeah, just keep in mind if you're using if statements, just use double equal signs. So if 1 equals 1, printf hello 1. Hello 1. I'm very creative. Okay? This is obviously going to print, but let's see, let's suppose that 1 isn't equal 1. So else, we write else, and we open curly braces again. Printf, I am bad at math. LOL. Don't forget the slash n, and then when we go and compile gcc test.c /a.out hello 1. Let's do 0 equals 1. So since this is not true, it jumps to the else statement. And I am bad at math apparently. Yeah, I am. But you know, you have this. And what if I shebang it, like make it a knot? When I make it a knot and I a dot out, I am bad at math because we are transforming a true statement to a false one. Okay? This is really important. And what about if we do 2 equals 1? Hello 1, because we are translating a false statement, you're negating it. So it's going to be true. Okay? So how about we do 1 equals 1 and 2 equals 2? Okay? I am saying okay too much, but okay, hello 1, it works because both of them are true. But what if we do R1 equals 2? We save hello 1. But 1 does not equal 2. But, again, but 1 is equals 1. 1 equals 1. And when we treat OR statements, we just not need to want to be true. Both can be true, but not necessarily. We can just like have one true and it will work. Okay, so let me do this. If one, wait, if one, okay. Oh my God. If one equals one, okay. And let me say else if. So I'll explain this. 11 equals 11, for example. Let's do this. Hello 11. So, and let's just do this. 0 is equals 1. We have hello 11 because the first one is false. Not true, false. The second one is true. And the third one, we don't know. We don't need to know because the else if is in the middle. So we don't need to get to the else because there is also an else if that it's like middle thing. It's in the middle and it if it is true, the else never gets executed. Okay? So yeah, that's the basics of if statements, else statements and everything. And yeah, I hope you liked the video. Bye bye.